In this video, let us see about the binary to BCD code converter. First, we will see what do you mean by a BCD code. Then, the step-by-step procedure is given to convert a given binary number to BCD code. What is a BCD number? BCD stands for binary coded decimal. Actually, this is a method used to represent decimal numbers. We know decimal numbers are from 0 to 9. So, BCD numbers also use the same 10 digits 0 to 9. The difference is that here the binary numbers 0 and 1 are used to represent the 10 digits. For example, you take this number 45. So, this is a decimal number. So, this number, it is written as, for 4, I will write 0, 1, 0, 0. That is, this is the binary representation for this 4. For 5, the binary representation is 0, 1, 0, 1. So, you have to separate the decimal digits and write the binary equivalent for each and everything. This is called binary coded decimal. So, this is decimal number. For each decimal number, you have to write the binary equivalent separately. You see this table. This is binary number. This is BCD number and decimal number 0 to 9 is given. Both till this decimal number 9, if you see both this binary number and binary coded decimal number, both will be same. There will not be any difference. But after 9, if you see after 9, so this is decimal 9, you see this yellow color things here. After 9, BCD and binary will be different. For example, you see this 10, I have to write it as, in binary we will write as 1010. So, this is 10. But in BCD, this should be written as, for this one separately I have to write 0001. And for 0, I have to write 000. So, similarly for 11 means, in binary we will write it as 1011. But in BCD, it should be written separately. Now, another example, let us take 2. 2 is 0010. Whereas if it is 52, I should write for 5 separately 0101 and 2 separately 0010. So, in BCD, we have to separate the decimal digits and write the binary equivalent. Now, let us find the procedure to find the BCD number. So, how to get this BCD number? For decimal number greater than 9, you have to add 6 to the binary number to get the BCD number. For example, you take two decimal numbers 4 plus 8, it will give you 12, which is greater than 9. Now what we have to do? You have to add 6 to this. Let us write the binary equivalent for this one. For 4, it is 0, 1, 0, 0. For 8, it is 1, 0, 0. So, if you add, you will get 12. This is the binary equivalent. You can see here, this is a binary equivalent. But this is greater than 9. So, add 6 to it. What is 6? 110. So, add 6 to it. You will get 1. This 4 digits will correspond to 2. So, 1, 2, we will get 12 as the answer. So, this is the way to convert a binary number to BCD number. For decimal number greater than 9, you have to add 6 to the given binary number. Where this BCD is used? It is mainly used in digital clocks and calculators, because you can see we have to display the digits separately, 1, 2, like that. So for that, this BCD is very useful because it will simplify the process of displaying the numbers. If you want to display 1, 2, for 1 it is 0, 0, 1, and for 2 it is 0, 0, 1, 0. You can write the coding easily. So for that purpose this BCD code is used. Let us see how to design a binary to BCD code converter. Now let us see how to design a code converter. Write the binary value and BCD value. So binary, it is represented as 4 bits. I have taken A, B, C, D. So it depends upon the book. So some might be following a reverse order like D, C, B, A. Okay. Always stick to one notation. It will be easy. Okay. Because if you change the notation, your answer will change. So always follow same pattern for all code converters, because you are going to study about XS3 code, gray code, all those converters. I will be using the same pattern. So you stick to one pattern. So I am using A, B, C, D. A is the MSB bit and D is the least significant bit, LSB. And here BCD, because till 9 4 bits is enough. After 9, that is for greater than 9, you need 5 bits to represent the BCD number. So it will be a 5 variable one. So B0, 1, 2, 3 and 4. Okay. Then this is the decimal number. So first you identify the input. Input is the binary number, which is a 4 variable function, and BCD is the output and it is a 5 variable function. We have to design using logic gates. So for that implementation, you can either go for a K-map to find the relation between input and output, or you can use some expression also. So here I am using K-map to find the relation between input and output. So binary to BCD number, first variable is, you see 4 variables are there. So I need a 4 variable K-map. And the first variable I am going to find is B0. Okay. So for B0, I have to get some relation in terms of the input. So let us mark this one. This is B0. Take a 4 variable K-map. You see here, what are the min terms which is having 1? This 1, 3, 5, 7, 9, 11, 13, 15. Okay. So all these are having 1. Remaining things are 0. I am not marking the 0. If you want, you can mark 0 or leave it as such. So mark 1 alone. You can club all the 1 together. So what will be the common term for these two? D. So B0 is equal to D. So one variable, you have got the relation between input and output. Now we have to find for next variable B1. For B1, 2, 3, min terms 2, 3, 6, 7, 12, 13 have 1. So mark those things here. You can club all the 4 ones together, and these 2 ones can be clubbed together. So what is the common term here? For these 2 rows, it is A bar is common. For these 2 rows, C is common. So A bar C. For this one, A B, what is the common term? C bar. So A B C bar. So we have finished B1 also. Next we have to find for B2. So B2, you mark the minterms 4, 5, 6, 7, then 14 and 15. So all these 4 ones can be clubbed together, and these 4 ones can be clubbed together. So we can find the relation for B2. So the common term here is A bar B. For this one it is BC. Next we have to find for B3. So B3, only 2 ones are here. Mark that one, 8 and 9. Club it. So you will get A, B bar, and common term is C bar. Next we have to find the relation for B4. So B4, here we have 1. So mark those ones, then club the ones together. So you will get AB plus, for this it is AC. Now we have found the relation between the input and output. So all the 5 variables we have found. Let us design it using logic gates. A, B, C, D. So 4 inputs are there, and its complement A bar, B bar, C bar, and D bar is there. So now what is B0? B0 equal to D. So directly from D you connect a line and mark it as B0 equal to D. Then what is B1? A bar C plus ABC bar. So A bar C. So A bar is this line. Then C is green line. Then A is here. B, C bar. Okay. So this is one AND gate and this is another AND gate, and both the AND gates are connected through a OR gate. So 2 AND gates and 1 OR gate is there, which will give you the output B1. Next B2 is given by A bar B plus BC. Again one AND gate, here one AND gate, 2 AND gates which are connected through a OR gate. Then B3, we have A, B bar, C bar. It means that only 3 input AND gate is required. So AND gate is here. For B4, AB plus AC, so 2 AND gates and 1 OR gate. So we have implemented the circuit. Binary to BCD code converter is this one. We have to give the binary bit here, and you will get the corresponding BCD code here. So if you are not sure how to draw this K-map, you refer to this video, 4 variable K-map. So you will understand the basics of K-map. And in this Read Electric Vehicle channel, we have already covered these subjects: power electronics, solid state drives, circuit theory, and basic electrical engineering. If you need any material, you can refer to this. If you like the video, do subscribe to Read Electric Vehicle channel. Thank you.